All right, so we are going to be going to the Earth's interior review. I'm starting with number one. The world map below shows Earth's major tectonic plate boundaries. Letters A through D represents four surface locations. Which location is on a convergent plate boundary? All right, so when I take a look, I know automatically, I know automatically that I'm going to be looking for the convergent plate boundary, and I'm looking at what page that will show me that information. Page 5. All right, so when I'm looking at page 5, I'm looking for the symbols, all right, where the plates are heading towards each other. That's showing a convergent plate boundary. When I'm looking at this map, I'm going to check where A, B, C, and D is on page 5 of the reference tables, okay? So for example, the eastern part of Africa, remember, Africa was cut off, so A would be around here. B represents a part of India, right? And so B would be right here. C is the middle of the Pacific Plate. And D ends up being right here, the Scotia Plate. Now, out of A, B, C, and D, the one that shows me a convergent plate boundary where we see these symbols is going to be right here. And so the correct answer is going to be choice B. All right, number 2. The theory of continental drift suggests that so remember that continental drift talks about how the continents are continuing to move, right? So where the continents are located now, the theory suggests that that's not where they were, many, many, many years ago. And so we're going to see which of these options help support that theory. So one famous theory is that the continents they used to be all connected together, right, into this supercontinent called Pangea. And then they broke up just like pieces of a puzzle. And so one of the main ones we see here is how South America, we don't have to use this map, we can use page 4. South America looks like it can fit the west coast of Africa like pieces to a puzzle. And that's why the correct answer is going to be choice D. It can't be C because it talks about how South America and Africa are moving towards each other. But when you take a look on page 5, that shows what's going on. South African plate and the African plate, look at the arrows. They're actually moving away from each other. And so that's why that statement is not even true. So the correct answer is D. Number 3. Number 3 says, what are the inferred pressure and interior temperature at the boundary between Earth's outer core and the inner core? And they give us options about the temperature and the pressure. So when I look on page 10, and I'm looking, the boundary between the outer core and the inner core is right here. And so I need to identify the pressure and the temperature. So right here, this is where the pressure is. And when I draw my line, it definitely looks to be a little over 3. It definitely looks like 3.1 or 3.2 million atmospheres. All right. And now when I'm scrolling down for the temperature, right, still following that boundary line, you hit where it says interior temperature, and it definitely looks to be less than halfway, right? And so because it's less than halfway, it has to be a number that is definitely less than 6,500 degrees Celsius, right? So in this case, based on the options, 6,300 degrees Celsius looks like the best answer. And which one shows 3.1 million atmospheres and 6,300 degrees Celsius is going to be choice 1. All right, number 4. It says, as the distance from the mid-Atlantic ridge increases, the age of the ocean floor surface bedrock does what? So what I have here is a quick diagram of a mid-Atlantic ridge. It's a mid-ocean ridge. And we know that new crust forms right at the ridge. And so the rule is whether you're heading to the left or to the right, the age of the ocean floor increases. So as long as you're starting from the mid-Atlantic ridge to any other location, right, the age of the ocean floor is going to increase. And so that's why the correct answer is going to be increase only. Choice B. All right, number 5, a model of Earth's internal structure is shown below. And so within structures, we see all the layers of the Earth. And it says analysis of which type of data led to the development of this model. Now, we've learned in class, right? Mankind, right? We haven't physically gone to the center of the Earth. We have not physically done that. So how do we know? We study earthquakes, right? By studying earthquakes, we have an idea. Oops, sorry, my spelling is horrible. By studying earthquakes, we have an idea of what the Earth's layer is even consisted of, what it looks like, and even to get an idea as far as the structure of the Earth's layer. And so by studying earthquakes, that's why the correct answer is going to be choice A, seismic waves. Number 6. It says true or false. A hurricane on the ocean floor creates a tsunami. That is actually false. Does anybody know what creates a tsunami to make this true? Actually, it's a earthquake. All right, an underwater earthquake actually creates a tsunami. So the correct answer is A. Number 7. It says basic answers to the following question on the block diagram below, which shows a tectonic plate boundary. All right, and so we see, so some key things that we see here, if people may not remember, but this definitely is showing a convergent plate boundary, right? I see trenches, we'll call them mountain ranges that are created, the oceanic crust is sinking underneath the continental crust. So it says compared to the oceanic crust, the continental crust is what? So we know whether or not it's dense or less dense because when we look on page 10, right? The continental crust, it says right here, the continental crust is actually 2.7 grams per cubic centimeter, and the oceanic crust is 3.0. So that lets us know, number 1, that the continental crust is less dense, right? So that means that I can cross out B and I can cross out A. Now, when I see to determine whether or not it's more mafic or felsic, take a look at page 10 again. It tells us the rock that makes up the continental crust. Granitic sounds a whole lot similar to the rock called granite. And where do I find that information? Page 6 of the reference tables. All right, so when we go to page 6 of the reference tables, here we go, it's going to tell me whether or not that this rock, right, that makes the continental crust, is it going to be felsic or is it going to be mafic, which is labeled right here. Now, granite is on the left side of the chart, which means that it has felsic material, so not mafic. And so because of that, my correct answer is going to be choice C for number 7. Sorry, guys. Correction is actually supposed to be choice D. We just said it's supposed to be more felsic. I apologize. Choice D for number 7 is the correct answer. All right, number 8. The diagram below shows the collision of an oceanic plate and a continental plate. Collisions between oceanic plate and continental plates are thought to result primarily from, well, what is the reason why these plates are moving, right? These plates are moving because of the hot molten rock that's below it that's occurring in the asthenosphere, right? It's causing for the plates above it to move. And so the direction of where this hot molten rock is flowing, it flows as a result of convection currents in the mantle. Choice B. Also, if you wanted to look at page 10 of the reference tables, you can actually see right here, sorry, these arrows represent convection currents, and this occurs in the plastic mantle, right? Which is part of the general mantle overall. So that's why that's the answer. Number nine. Number nine says identify the subducting plate and the overriding plate for the Mariana Trench, right? So where am I going to find the Mariana Trench in order to find the subducting overriding plate? I'm looking at page 5 of the reference tables. Now, if you look right here at the bottom, they tell you right here that in a convergent plate boundary, right, they tell us the subducting plate and the overriding plate. The overriding plate is the one that has the boxes, right, facing it. The subducting plate is the one that does not have the boxes. So let's keep that in mind. All right. So let's look for the Mariana Trench. And when I look at the Mariana Trench, I see that it's located right here, right? And so what are the two plates? There's the Pacific plate and there's the Philippine plate. Which one has the boxes facing it? The Philippine plate. So because the boxes are facing the Philippine plate, when I look at the key, once again, they tell me right here that the boxes facing the plate is the overriding plate. So therefore, I know right here, my overriding plate, is actually going to be the Philippine plate. And so the subducting plate is actually going to be the Pacific plate. So once again, Pacific plate is the subducting plate, and the overriding plate is the Philippine plate. All right, number 10. Number 10 says, which cross-section best represents the conventional currents in the mantle between the Peru-Chile Trench? All right, so when I'm looking at page 5 of the reference tables, the Peru-Chile Trench is located, oops, sorry. The Peru-Chile Trench is actually located right here. And I'll zoom in for you guys. There we go. Yep. Now, what type of plate boundary is this? Well, based on those symbols, it's definitely a convergent plate boundary. And what does that mean? It means that the plates, right, are coming towards each other. So when I'm looking for my choices, I need to make sure that I'm choosing movements that show that the plates are moving towards each other. And so that's the reason why the best answer is going to be choice C. Look at how the convection currents are located right here as they're moving towards each other. That's why the correct answer is C. They're the only ones that where on the surface, right, that it's actually moving towards each other on the surface. Number 11. It says basic answer to the following questions on the map below, which is an enlargement of a portion of the tectonic plates from the Earth science reference tables. Points A and B are locations on different boundaries of the Arabian plate. It says identify the type of plate boundary located at point A. All right. So located at point where point A is. And it looks like it's kind of diagonal, a little bit diagonal between the African and Arabian plate, right? So I want to identify where would point A be on page 5 of the reference tables. And so the Arabian plate is here. The African plate is on this side. And so point A would be actually located right here. Now, what's interesting is that I got to look at this line and what symbol does it mostly reflect, right? So that single line, right? Does it reflect divergent plate boundary where it's a double line as we see here, right? Nope, it doesn't. It's not a divergent. What about convergent plate boundaries where we see the symbols of boxes? Do we see that there? Not at point A. We see it in other areas, but not at point A. This single line, honestly, it matches up with the transform plate boundary. Now, it could be that because of this diagram, the arrows can't really fit right in this area. And so that's the reason why we're just looking at the symbol. And so that's the reason why when I'm looking at this singular line right here, right, the singular line right here, the plate boundary that it matches the most is transform plate boundary. And so that's your answer. All right, number 12. Number 12 says the pie graph below shows a composition in percentage by mass of the chemical elements found in an Earth's layer. And they give us the pie chart below. The composition of which Earth layer is represented by the pie graph. All right. So number one, I'm going to look at the top two elements, right? And I see oxygen and I see silicon, right? With 46.1%, silicon 28.2%. The other thing I see here is they're showing the composition, right, in percent by mass of the chemical elements found in the Earth layer. Composition percent by mass of the chemical elements found. Doesn't that look like the title of a page on the reference tables? Right? The composition of elements found in the in an earth layer. And if I take a look, chemical composition and the earth layer talks about, I see it says the earth's crust, hydrosphere, and troposphere. All right. Now, guess what? Remember, oxygen was 46.1% and silicon was 28.2%. I remember seeing percent by mass like we saw right here. So it's evident and clear that this is focusing on the Earth's crust. And so that's why the correct answer is choice A. All right, number 13. Number 13 says, which diagram best shows the type of plate boundary found between the China plate and the Philippine plate? All right. So once again, I'm going to be going to page 5 of my reference tables. Now, what's interesting is that when I'm looking, I see the Philippine plate right here. But you know what I also see that's very interesting? I don't see the China plate, right? I don't see the China plate. Now, you may know, okay, hey, the China plate must be associated with the Eurasian plate, right? So it must be somewhere in this area over here. But let's say that you didn't even know that. Let's say you didn't know that. When I'm looking, all of the symbols of the Philippine plate are showing me convergent plate boundary. All surrounded in the Philippine plate, I see the boxes, the symbol with boxes. And that shows me that this is a convergent plate boundary. Now, if we remember, convergent plate boundaries has the plates coming towards each other, right? And so therefore, when I'm looking at my option, which ones show where I have the plates that are coming towards each other? And it's going to be choice C. And you're able to come to that conclusion even if you didn't know where the China plate is, you just knew for a fact all the boundaries of the Philippine plate is a convergent plate boundary. And convergent plate boundaries, or the plates, they move towards each other. That's why the correct answer is choice C. All right, number 14. Number 14 says the photograph below shows the East African Rift Valley in Africa. Which tectonic movement in Earth's crust is most likely responsible for this feature? All right. And it says either convergence of continental crust, convergence of oceanic crust, divergence of continental crust, and the divergence of oceanic crust. Well, they're telling me that this is the East African Rift Valleys. And so even if you forgot what plate boundary creates rift valleys, okay, let's take a look on the reference tables. And I'm looking at the East African Rift Valley, which is located right here. All right. Now, what do you notice about, right, about the direction that the plates are moving? They're moving away from each other, right? If they're moving away from each other, doesn't that movement show something similar to the divergent plate boundary, where plates are also moving away from each other? And in class, we've even learned that rift valleys are created by the divergence, all right? Now, the East African Rift Valley is seen on a gray area, right? It's seen on a gray area. You know what that tells me? That gray area represents land, the continents. And so that's why it's going to be divergence, right? Because it's a divergent plate boundary of continental crust because it's on land. Choice C. All right, number 15 says, base the answers to the following questions on the map below. Letters A through F are locations on Earth's surface. And so it says, which location is closest to a divergent plate boundary at an oceanic ridge? Which location is closest, keyword closest, to a divergent plate boundary at an oceanic ridge? And the options are location A, B, C, and E. All right, so I need to find A, B, C, and E on page 5 of the reference tables. So let's take a look. All right. So, and you have your paper with you. So I know A is located right, oops, sorry. A is located right around here, right? That's where A is located. B is on the west coast of South America. So B would be located somewhere right here. All right. C is located on the northeastern coast of North America. So C looks like it would be somewhere around here. All right. And then E is located way up north, right, where this part of Greenland, I believe. Right, so way up north for E. And keep in mind, guys, you do have the latitudes to help you, right? You do have the latitudes here to help you. So I know E is somewhere that is many degrees above where C is, right? So in this E may be somewhere around the left side of Greenland. So E may be somewhere around here. So between A, B, C, and D, which one is close to an oceanic ridge, a mid-ocean ridge, right? And a mid-ocean ridge is going to be in a divergent plate boundary, right, as seen here. And so it should have symbols like these, okay? And so the one that's closest to this type of symbol is A. A is closest to the mid-ocean ridge. And so that's why the correct answer is choice A. Number 16 says, based your answers to the following question on the information diagram below. At intervals in the past, the Earth's magnetic field has reversed. The present north magnetic pole was once the south magnetic pole, and the present south magnetic pole was once the north magnetic pole. A record of these changes is preserved in the igneous rocks that formed at mid-ocean ridges and moved away from the ridges. The diagram below represents the pattern of normal and reverse magnetic polarity in the igneous rocks composing the ocean crust on the east side of a mid-ocean ridge. Which diagram best shows the pattern of normal and reverse polarity on the west side of the mid-ocean ridge? All right, on the west side of the mid-ocean ridge. All right, so therefore, when I take a look, the mid-ocean ridge is right here. And one thing we learned is that the magnetic polarity, the eastern to the east of the mid-ocean ridge, the pattern has to be exactly the same. So if I started off with normal, right, white, reversed, long gray, normal, short white, and reverse long gray again, then when I'm starting from the middle to the left side, I need to see that same pattern, right? I should see starting from the ridge, I should see short white, long gray, short white, long gray from the ridge. And the one that shows that is choice C. Short white, long gray, short white, long gray. Number 17, it says, base your answers to the following questions on the block diagram and all your knowledge of earth science. The diagram represents the pattern of normal and reverse magnetic polarity of the seafloor bedrock on the east side of a mid-ocean ridge center. The magnetic polarity of the bedrock on the west side of the ridge has been omitted. Arrows represent the direction of seafloor movement on either side of the ridge. Complete the diagram by shading the pattern of normal polarity on the west side of the ridge center. Assume the rate of plate movement was constant on both sides of the ridge. Your answer must show the correct width and placement of each normal polarity section. So they give us the pattern, the pattern polarity from the ridge to the right side, right? And so therefore they want us to draw how would it be on the left side. Now keep in mind the pattern, it has to be symmetrical, right? So that means if I go from 0 to 5, 10, 15, 20, if I go from 0 to 15 with gray filled in, you gotta fill in 0 to 15 with gray, right? If it's up to the third line here filled in gray, then 1, 2, 3, that third line also has to be filled in with gray too. 1, 2, 3, 1, 2, 3. Yep. So this got to be filled in too, right? Then I look, white is from this third line to the 25, it's white. So from the third line to 25 is white, and I'm going to connect my lines. Then from 25 to one line over, it's shaded gray. So I'm going to do the same thing. From 25 to one line over, it is filled, shaded in gray. Notice how my width has to be exactly. You're not estimating, right? You have to shade the correct width. Then from here, 1, 2, 3, 4 lines, right? Up to 50 is white. So from here, 1, 2, 3, 4 lines have to be white, no shaded in. And so I did that. All right. And then from 50 to 2 lines over is shaded. 50 to 2 lines over is shaded. All right. And then the rest has to be white to 75, and the rest is white to 75. Then after that, you can just kind of clean up on the, you can just clean up. You can just clean up the sheet, all right? And it should be symmetrical to the right edge. And I'm just gonna put the answers so that way you can see. It should look like this. So you can pause the video and check if your answers are correct. Make sure to check that your widths are correct as well. It has to be identical, right? Whatever you see from the ridge to the right has to be the same from the ridge to the left. All right, so number 18, it says basic answers to the following questions on the map below. A knowledge of Earth science. The map shows the general ages of surface bedrock of Iceland. Keep that in mind. An island located on the mid-Atlantic Ridge Rift. That's also something to keep in mind. The location of the mid-Atlantic Ridge Rift is indicated. Points A and B represents locations on the surface bedrock, which is igneous in origin. The ages of the surface bedrock in millions of years are indicated in the key. All right. On the map, identify the two tectonic plates, one on each side of the mid-Atlantic Ridge Rift at Iceland by writing their names on the lines provided on the map. All right. So first, I know that there are the Mid-Atlantic Ridge, right? It connects this entire, as we see here, right? Mid-Atlantic Ridge, Mid-Atlantic Ridge. It connects this entire region right here, okay? And we know they want to know what the two plates, and we have to write them right over here in this area, right? Right over here, this area. All right. Now they give us a location. Not only do they tell us that, okay, hey, it's in Iceland, right? But they also give us some latitude coordinates. So it's definitely in the 60s degrees north. And this area is somewhere between 14 to 22 degrees west. So when I go on page 5 of the reference tables, right? 60s degrees north looks like it'll be around here, and 14 to 20 degrees west looks like it'll be right around here. So that means this area is possibly going to be around this region. All right. And it says island hotspot right here. All right. And so now when I zoom in, right, now there's two plates that separate the Iceland hotspot, the Eurasian plate that's on the right side and the North American plate that's on the left side. These are my two plates. So how would I write it? The Eurasian plate. Sorry, hold on. Let me just erase this here. The Eurasian would be given here, and up here would be the North American plate. And those would be your answers.